All right. So, welcome everyone. Welcome to the session. I would say the webinar on career for future in electric vehicles. So, I'm Suraj. I'm the founder and CEO of Decibels Lab. I'm also the course director of electric vehicle powertrain courses at Decibels. So, this webinar is organized in partnership with Stumax, and so Stumac has been a great, accountable company across the state and across the country in connecting with students and helping to their career opportunities, and also engage in various different activities across the universities and colleges. So thanks for the team at Stumac who have been made all this possible to host this webinar right for today. Starting it ahead, so this is what I quote from my side to put it across. I really don't know who you are and why you are attending this webinar. Maybe you're from different parts of the country and you're engineers, you're working somewhere, maybe you're an enthusiast who want to learn about EVs and things like that. But I don't know what you want to do, but on the reality side, our nation need skilled engineers to go ahead in days to work in the EV technology, to make better products and create EV services. This is a motive. It all interests us than just a business and operations, but at an overall scope, at a bigger way and bigger, like a nation-wise. So this is what we need. We need a lot of engineers because we if we have to come up with a lot of products which are better in a place where we say, okay, there's a Tesla, there is X, Y, or Z, but what we have from our country, right? And which we can position into an international market and things like that. So we need better engineers to create, and how many products we have brought to the market in EV. So vastly, we do depend upon a lot of other countries for components and imports and things like that. So, but yeah, the things has to go the other way, and manufacturing has to start here, maybe technology development has to start here. But if it has to start some point, and we need engineers, right? We are the people, possibly assuming everybody here are engineers. We need all of you to work on it, and to create products and create solution, and develop amazing things into the market. That's the motivation for all of us, and that's the motivation I had to deliver this webinar to. To setting up things into a place, here is a bit of a flow on the webinar. So I would introduce a bit about Decibels, and I would also, as I just spoke about, Stumac, and we set the webinar objective, and then we move on to understand the startups in EV in India and globally, and we also understand the global EV OEMs, and then we'll get technical in understanding EV subsystems, right? So then at the third point, we will move on to understand the career opportunities. I have mentioned 3 departments majorly, so everything else would possibly come under that. Maybe I would have, computer science is not majorly, I've mentioned it here. So, but apart from it, yeah, everybody sees their own importance of a job, because EV is not something, there is no job for a mechanical engineer, for the guys out there who are mechanical engineers or production engineers. There are opportunities for all of you, right? So we will explore what are these opportunities are. And majorly, yes, there is an electronics and communication side, and also on the electrical and electronic side, because it's electric, right? So you have components and things like that. So we would get deeper in understanding and also see the components and understand what is the importance of all these components, right? And then at the last we'll see, okay, what if we want to start a career in EV, so what we really should learn and what skills the industry is expecting, right? So this is what we would go through. This is a webinar flow. I'm expecting this to fall for 60 minutes. Maybe depending upon the QA and depending upon the questions you would ask, maybe we would expect it to maybe go a little extra. And I believe you have time scheduled a little bit extra so that we can have a discussion side, right? But this is a sort of a set foundation on what we wanted to discuss with you for today in the webinar. And well, introducing a bit about Decibels. Excuse me. So LMS.Decibels Lab, it is an e-learning platform from LMS, e-learning platform from Decibels. It's specifically a platform for a career-oriented, affordable learning for engineers, where there are more specific courses and technologies of EV, so that you could start your career in the EV sector. Maybe you're a fresh graduate, or maybe you're a engineer working in the industry. You can take up our courses, which will be equivalent to years of 1 year experience and things like that. So we help also to people to get a jobs. That's what LMS.Decibels Lab does. It online courses and through experienced industry experts. And the second area, we do consulting in electric vehicle powertrain and the new product development and manufacturing sector. A couple of our co-founders sits in Sweden, so we consult few companies there, and then we consult few companies in India. And on the other side, we set up labs for research and development. We have few colleges and universities, and also a few companies. We have set up labs where they can do a testing of the batteries, automotive electronics, development components, and things like that, right? So that's what we do as a part of the Decibels lab. And the last one is, because we train a lot of people, the industry asks us, okay, you have a trained people, can you send the candidate resumes, and can you just help us to find good engineers? So yeah, we do help a lot of what I say companies to find candidates. Did I mute the audios for the people out there, Galaxy 51 and Chintala Tejasri? So, right. So going ahead, yeah. So the next slide, we will talk about EV startup in India. The objective is not here to just kind of tell you that, what is this company name, sir? But the very important point is, see, when you learn something, right, you're going to like spend 1 hour today, and let's say you take up our courses, you spend like quite a lot of time. But, are there really jobs available? Are the companies working on EVs in India? So can I at least get an internship for right now if you're a student? Where can I apply for a job? What kind of specific roles are they looking for? This is what it matters, right? Because, in engineering we study, but where do we apply a job? Which companies are there, which you are not clear about, right? So that's what a first and foremost foundation I want to set. We want to understand the market first. Okay, are there companies really? Are there Indian companies? Are these companies looking out for engineers into our place? So that's the purpose I brought up the list of startups. I'm not like telling that I've done every list here, but I've brought in as much as possible so that I can share it across to you. But there are many other startups. And it's not something I'm discouraging that I didn't list it here. Possibly whatever I could find, I've put it here into a place, right? So if you see on the screen, you see Ola Electric Mobility, which has been very well funded by SoftBank, closer on $250 million. And you see Ola Electric Mobility, the same company, also been funded by other partners. And then if you see Ather, which has been funded by Hero, and then you have Smarty, you have Yulu, and all these companies, right? So I want you to just take a screenshot and keep it with you so that it's good for you if you want to look for a career opportunities, at least for an internship, right, with any of these companies. So these are the companies which I've listed few here. So I believe this gives you sort of insights in understanding, okay, there is a potential if I learn about things on EVs. So if you see here a few more which I've listed, eBike Go and Mflux Motors, they're based out of Bangalore. Gaim Motors Works, Ion Energy, again, it's one of the biggest battery pack manufacturer in India. And yeah, there are a lot of companies which I could not mention right here, but yeah, definitely there are many other companies to accept this. If you see here, I'll just run through a few slides to kind of understand a bit of about these companies. If you see it way back few years, it started in IIT. And if you see their images and videos in internet, which is available, let's say Ather starting video or something like that, you could see a very basic sort of a video where they took a vehicle, they put a couple of components onto it, and they tested it in the college campus. They built a team and went around, and then now it is one of the India's valued company, right? So Ather is considered to be one of the very biggest startup in India in the electric segment. So if you see it here, that the whole difference is, a few years back, if you consider any of these bikes and cars, right? Who used to build these bikes and cars? Like Hero builds it, or somebody like Mahindra builds it, or Tata Motors, or any of these companies, right? But you never seen out of the college students would start a startup and then they build a vehicle, and that becomes one of the famous vehicles in India, right? So, but you see that happening in the other way around, because it's electric mobility, right? There are less components, the system is more in a different way, the technologies are advanced, it's easier and quicker to develop an electric vehicle from everybody's side. So people are doing it. So that's the whole different side of it. It's not that only the big companies like Tata Motors or with a millions of fundings can only do it, but also the smaller companies can do it. Maybe the Ather was just started in a college and then now it just progressed to a far away and what it is right now. Similarly, you should see Yulu. It's another startup based out of Bangalore. They have 4,000 vehicles right now on the road, and it's IoT enabled micro mobility kind of a thing. And recently Bajaj pumped in around $8 million, and that's close around 54 crores, right? Nearly. So the thing is, they have around 4,000 vehicles. I was reading an article a few days back that they would like to bring in another 90,000 vehicles into the market, onto the roads. So if they want to do it, let's say even each vehicle earns 20 rupees a day, and you could count like 20 into 94,000 vehicles. It's a hell lot of money, right? Just making some math, as every accountant does. So that is a potential. It's a hell of a lot of money. Why don't an investor invest some money into it, right? And it's very simple. You have a phone app. You can just take it. You can go and unlock it and take it ahead. That's how you see the companies are doing things. And then Ampere is there, which is I think based out of Chennai or Coimbatore, which has been recently acquired by the Grievous Compton Grievous. Sorry, Grievous Cotton. So for somewhere around like a 60 crores of a deal or something. So again, started like way back in a few years, and then they've made decent revenues. It has been acquired now. It's a pretty big company. And now you see Ultraviolet. Ultraviolet is another startup based out of Bangalore. So again started by a few of the alumni from BMS College of Engineering in Bangalore. So if you see today, they got a huge funding from TVS, and they're trying to kickstart their vehicle into the market. And the same like an Influx is there, and then you have Pure EV, and then you have Torque, which is based out of Pune, and also been sort of backed by Ratan Tata. And then you have e-bike, and then you have Ola Electric, and you just go and type it in internet or in LinkedIn how many jobs opening Ola Electric has today, right? It's a huge number of people they're looking for. But then you have other startups also. Like I don't take much time here, but I wanted to show you that there are companies, there are people who started the companies at being out of college, and even the professionals too. But there are opportunities in all these companies. And then not only in India, if you see globally, there are a lot of other startups like Unity. If you have attended it 2 years back, Auto Expo, not this year, the year before. So Unity was there in bank, in Auto Expo, and then other startups into a place. And then there's this one in this, like there's a car right, the right hand middle of it, in the middle of the screen below. So this is called Sono Motors. They developed a whole vehicle, and they almost ran out of their money, and they were looking for investors. Not anybody was interested in doing investments majorly. They went for crowdfunding and to raise $75 million. And I'm not just telling a bluff story. You go and check it on the internet. They raised $75 million in crowdfunding, and also there are private equity funds who have given the money, but they did it, right? So this money is not a problem if you have enough technology solutions available to the market. That's what I see. It's not only that big guys does it, EV. It's also that anybody can start a startup. Anybody can build products into a place if you have that kind of a team and a right supplier network. Have a mature knowledge about a market, testing requirements. How to acquire customers into a place, and that's what a potential of EV is all about. And this is a bit about EV side. I did not mention any of this other companies. Nothing could go wrong with it, but just want to limit number of pictures that we can discuss more about technicals. So on the other side, if you see, this is a report from McKinsey. So McKinsey is a very powerful consulting firm. So they do a lot of market research and publish the data. If you see here that, right, EV line by global OEMs. So established OEMs, I'm talking about only the OEMs, not the startups, are expected to launch around 400 new electric models by through 2023. And if you see the numbers which is here around, it's a huge global numbers what OEMs want to bring into a market. When OEMs has a plan, they have a money being figured out, right? So it's not like, okay, the coronavirus comes and we're going to start up all these things into a place. They have very well funded banks, and they have very well funded equities, and they have very well managed money to build their products. It's not like something happens in the market, we're going to stop everything. They have plans. People, because I speak to my friends in US, I speak to a couple of our customers in Europe. They all say, okay, things are there bad right now, we will definitely, we are still nothing wrong about the situation. We are very positive. We're building the products into a place. So if you see this very capable on the screen, that there are so many vehicles are being expected to release by 23, which means the question lies here that we need engineers to develop these products, right? We need engineers to work on this technologies, work with these companies, because not just a bunch of engineers out there who can do everything, because the people who are there are not specialized in EVs, like they would be working in something else. But it requires such a specialization in EVs to work in EVs, because the tech is totally different than an ICs, right? If you consider about a powertrain, basically. So we need engineers. We would need them for every single requirement of a new tech in EV. So that is what is an importance of all my slides, which I presented a little few minutes back. So if you have any questions right till here, you can just drop me out. I can take few questions, and I should be able to go across for the next uh, slides. So I'll take a minute here. If you have any questions, just drop me questions here, that we could see some answers. For the questions that I asked before, I would try to answer it back. So I've seen job opportunities which requires minimum 5 years of experience. Is that true? It needs a much. Nikhil, there are a few job roles, okay, which do require experience, because if you take about testing and things like that, a high level product development, these things will definitely take few years of experience. They only take few experienced engineers, but there are widely people are accepting freshers for many other roles too. So depending upon kind of a skill sets you have and things like that. So because right now, if you see today, right, there is no college actually. I would say fairly there is nothing such a quality sort of a content available with any of the faculties to deliver sessions. Because if you see, EV itself has very been in a recent into a market. But if I interact with a lot of faculties at universities in US or in Germany or in Europe, they have already introduced the subjects way too back, and we still do not have a subject itself in our courses as of today, majorly. And if you do have just like sort of very basic definition of EV, basic components, we don't use simulation tools to build the models. We don't understand in-depth board. We don't have testing facilities. We don't have like labs which are on EVs, maybe low voltage or high voltage labs. So okay, what we could get an exposure is very less if you are just a graduate. Maybe even if you take few courses also, there are few courses only available just to give you a very, very basic understanding. So that's what we're trying to address maybe on the down slides. But it requires some deeper exposure before you graduate. Maybe it's like thermal, you have studied subject, but not about electric vehicles, right? Maybe that is one parameter you may have to know a bit, but further on, you would be definitely able to understand, find some opportunities, which I could see from my side, because a lot of startups which we consult are asking for engineers. Hey, Suraj, there are a few engineers I need. Can you just send it across to them? They're freshers. If they know all the EV systems, that's fair for me, right? So with my experience, I've seen it, but yeah, I don't know about what possibly else is, but yeah, there are people required for experience to things. Hey, I'm Ajay. I'm a fresher in MTech and drives. So how to move into EV technology? Cool. I'll answer it back to you. Maybe I'll go through the technical sessions and I should be able to answer it back to you. Cool, guys. I'm very glad you're getting questions into a place. I would continue my session. I'll take back the questions. I start with Nikhil's question. Maybe I'll just go ahead and take it ahead. And guys, this is only for 100 people. So session is limited for 100 people. If any of your friends are waiting, so just tell them that they can get a recorded session later on. Cool. Going ahead to the part of discussions about EVs. So let's start at a technical session. Okay. So we'll understand the subsystem in EVs. So in understanding the EVs, there are two different things. One people call BEV, or also they call it XEV. Okay. So BEV is specifically an electric vehicle which operates and powered by a battery. The source of only the energy is a battery, right? That's what we call as a BEV. There's something is called XEV. That is more about hybrids, plug-in hybrids, or micro hybrids. So the battery is not only a source of energy, but there is an IC engine also, which supports, which may not support for the power directly, but indirectly it may support in series hybrids, or it's a micro hybrid. It's basically a very simple thing. And then on the mild hybrids or plug-in hybrids, it's more of a complexities. Again, there is a battery pack. whatever components you see in EV, right? Those components are there inside even in the plug-in hybrid, but maybe the factor size is smaller. The maybe the smaller the components would be of a different size. Ratings are different and things like that. But you would see the same components in XEVs also. But the only thing is, XEVs are are more complex because you need to make two systems to operate together, and they tend to be more expensive because if you consider you're going to use all the components which are there in electric vehicle, again there is an IC engine in it, right? It requires a cost and things like that. So that's what one thing which you see on the hybrid side. Yeah, they are helpful. There may be transition between IC engines to hybrids and hybrids to EVs. But if you see, we didn't see much potential in the market. Not any smart hybrid is a very basic sort of an hybrid compared to what Prius is in the market. So we don't see much traction, right? Maybe FAME is there, subsidy is there, and because of that, a few EVs, XEVs came into our market, but not majorly as a very deep tech in hybrids. Second thing is more components, redundancy problems. Things can go failed, and that becomes very challenging to repair and things like that in the market. So we will not talk about plug-in hybrids or hybrids. We'll only talk about BEVs today because the plug-in hybrids would cover up similar components, but they're a little more complicated. We'll not touch base too much. And also as such, I don't see much companies working on that tech today in Indian market. And if there are very few OEMs who are working on it. So talking about EVs, let's say that's specifically BEV, battery operated electric vehicle. You can see all these components specifically, right? If I could start from here, because it's very important, all my session further on will based on this specific image, right? So let me go ahead and just draw a few things. Okay. So if you see here, there is a motor and then there is a transmission. So then apart from it, then you have an inverter, which is connected to the motor and also the battery pack. Then we have an onboard charger, and then we have a DC-DC converter, right? And then we have a battery management system, and then we have, let's say, the battery pack itself, right? And then there is something called a normal charging connector, and on the bottom side, you have a quick charge connector. I'm really sorry, maybe my system mouse has just gone somewhere. So on the compressor side, you have AC compressor, then there is a ECU, then there are a few other components which is there as a part of the EVs, right? So it's very important to understand what components are there in EVs. That's what we're trying to do, because all my session further on will be deep dive in understanding the system. And also I will emphasize on, if you're an engineer from a specific department of engineering, so I will emphasize on, okay, where you can actually get a job, right? So that's a very insightful thing which we're going to cover up here. That gives you, okay, if I work on this thing, this is what my direction of engineering in EV is about, right? So that's what we'll do. We'll touch base on motors. We'll touch base on inverter. That's basically a motor controller, and then the charger, and then the battery pack. I would say the cell and the a pack, and then the battery management system. We'll not go much in every single component, but we would understand, okay, what is the scope that you have as an engineer in these areas, right? So this is majorly a layout. The layout could be in many different ways for many different vehicles. But as such, this would be the sort of a very simple layout which I could bring up with. So let's go ahead and understand the next slide. I'm sorry. Okay, mouse has gone back. Sorry, there are some issues with the cursor, so it just happens. Okay, I'm sorry about the glitch. That was just trying to shift to the next slide, was not happening. So yeah, let's start with the traction motors, right? So because the motor is a prime mover, right? So which moves the electric vehicle. So it becomes a very important component in an EV. So if you see here, it's more of an electrical engineering, right? So we would know it from your studies perspective of it. And so majorly in traction motors, there are various types of motors. You could talk about a BLDC, there is a PMSM, there's an induction motor. And this is majorly type of motors what people are trying to use into their EVs today. And any type of motor it may be, but end of the day, somebody need to engineer that motor, because not the same motor is applicable for all the vehicles. Most of the vehicles have their own performance parameters. So the motor size varies, the requirement of energy density varies, and the cost is a challenging parameter in the industry. So putting it all these things together, if you see today, all the OEMs are working towards their own EV, the motor design. So one thing is not Tata Motors manufacture a motor, or let's say a company like Mahindra will manufacture a motor. They have a suppliers. Maybe you take a Mahle or a Bosch or a Continental, or there's something like startups like Yasa Motors, and there are so many motor companies, right, who manufacture these motors. And sometime maybe something like a Ricardo or AVL or FEV, all these companies will consult these OEMs in designing or engineering a motor. At the end of the day, they would have some partners who have a manufacturing capabilities and where the manufacturing will happen. So as an engineer, if you understand, you may not involve much in manufacturing until and unless you're into an electrical department. But if you see a very deeper insights about it, so where the phases which you involve in the design of a motor, right? So it's the specific type of a motor where would be involved in electromagnetics, where you'll use specific softwares like Maxwell or MotorCAD and all these things, where you'll be able to design a motor for a specific. So then once the motor is designed for the specific application, where you do a lot of different analysis. It's not just like electromagnetics. You can say, okay, there's enough magnets which I can put and I'll be able to do it. It's one part of it, and it's a very, very, very important part of it. Because today, if you talk about energy efficiency, it's very important, because we're expecting traction motors to be efficient, at least like close around above 80% efficiency, or like 90% efficiencies, right? So and even more than that, if industry is demanding, they would say, okay, I want as best as possible from anybody. So, but yeah, today's kind of it, if you see the image which is right below, which here it also tells about this efficiencies, which you see somewhere around 95% efficiency. And that becomes a very, very important thing in terms of designing, packaging, making it more compact, because we don't have too much big space in EV, right? So electric vehicles. So you want it to be specifically for that application. And the second thing is, it is not a standalone application where you're keeping the motor at a one place and running the motor. But in EV, so the motor is going through uh, enormous amount of dynamic situations. Maybe you take an example of, let's say, a weight, the load on the vehicle, load on the motor. So the motor load is continuously varying. If you take application like automation, right, you have a motor, okay, which has to open the wall, close the wall. The load is pretty much always defined for as a constant, right? But if you take an automotive application, you accelerate a vehicle, you decelerate a vehicle, you go at a constant speed, up will come, there's a hump on the road. You're doing all these accelerations as a customer, right? But at the end of the day, the motor is supplying all that torque which is required, RPM which is required for the wheel to run. So first thing is, it is undergoing a huge dynamic variations. So the motor has to support that requirements, right? It's not like a standalone application, and it will undergo a lot of vibrations, and it will undergo a lot of thermal shocks, because possibly, let's say you take a cities like Chennai or Mangalore or few other cities in up north, the temperature is very hot, where the ambient temperature itself is, let's say, 40 degrees Celsius. Then now, how are you able to ensure that the motor temperature when it is operating? It's become very difficult, right? That's why today in India, like a lot of us buy motors from China, a lot of startups, and a lot of even OEs also, because there is no option as such today, right? So when they buy it, like there in China, the temperature would not possibly go like more than 30 degrees Celsius, right? But here in India, we have temperature which can goes like zero, and it can go up to 45 degrees Celsius. But how can you expect the motor to operate at its best efficiencies? So this requires an engineering, right? This requires, because my last session, which I was delivering 2 days back, there was a faculty from IIT Madras about from the security department. We had a call later on that, right? So we had a very insightful discussion, because how different we need to understand the Indian market. We need to have startups in India to design, build motors and technology for motors in India. That requires engineering on the side of electromagnetics. That is majorly for electrical engineers, a degree in engineering, or let's say even things like that. And then, okay, because it becomes another crucial thing, right? Because the efficiency of the motor always depends on the thermals. One of the parameters, thermals. So, and then the torque and RPMs and things like that, and maybe it's servicing years and things like that. So thermal is very important factor. So when thermal is an important factor, we need engineers from the mechanical background to study the thermal behavior of a motor, ensure that the motor is always kept at the right temperature so that you can safeguard its regions of operation. And then the design of a motor itself is a mechanical engineering prospect of it. And then about your NVH is noise, vibration, and harshness. So because you're subjecting the motor into various different vibrations, so that could go through a different sort of failures in the motor. And also ensuring that the motor can operate at these variations is one more factor. That's what we study. A mechanical engineer would involve himself in developing it. And the other side of it, let's say the testing of this motor, because in industry, design is a one phase, but actually the testing is where it takes an enormous amount of money and time in developing a system. Because see, it's not something, okay, you give a motor and let's say it works. It is never like that, right? If something goes wrong with a motor, you will have to have a warranty claims. Warranty claims means enormous amount of money loss for the company. And it's a shameful situation in the market, right? You recall, let's say, 10,000 of your vehicles, first of all, where do you recall them? You need to recall them to the service stations. You need engineers to repair them. You need updates them. If it's a hardware issue, you're gone for a toss, right? The company has to invest again millions of money to put back the parts. So that is where it becomes very challenging in an application like automotive, where we need a lot of testing engineers. So where there is a different type of tests which we do, and a different type of studies which we do to suit a motor for a specific application. So that is where another set of engineers are required. I'll just mention few roles here. So there's a roles for even a mechanical engineer in the design of motors, and in the areas of thermals, in the areas of let's say NVH. I would say mechanical is more about a casing side of it, a casting side of the components, all the other components as such, which is required in the motors, and then the testing of motors. Cool. That's a bit about motors, which we see in the traction side of it. And if you go to the next one, that's basically the traction inverter side of it, right? So what is the meaning of traction inverter? Basically, it's a device, right, which controls the motor. So you have a battery pack, which is a DC, right? The energy stored in the battery output would be DC. So the motor is basically the AC. We use AC motors in all the automotive applications. So you need to convert an AC to DC. That's your first and foremost functionality. That's what we call as an inverter. And the second thing is it also need to control the motor parameters in terms of a torque, in terms of RPM, let's say in terms of its response, in terms of its operation regions, even in terms of its temperature control, like authentication of the inputs into the communication with the other components. So much of functionalities is there for the motor controller, right? So if you see, you could barely understand, okay, this is a guy from an electronics department who will be involved in designing all these components into a place. Actually, this is from Toyota Prius, which I have taken the details of the motor traction inverter. So if you can see there, you could find an enormous opportunities for electronics engineers and electrical engineers from let's say the power electronics background of it. I would say in terms of power electronics, sizing of all the components like capacitor, resistors, any of the circuits which comes as a part of it. Because on the side of electric vehicles, where we are talking about like 350 volts, 400 volts, like even applications like buses, we are going up to 700 volts, right? So then the motor is operating at a different region. So you need to convert all of that high volt system into the motor operating regions, and then control the currents into a place. And that is where we need a lot of engineers who work in these areas of, let's say, power electronics. And then the hardware design. So okay, the electronic circuitry is put into a place, then it requires, again, all these PCBs has to be done very newly, right? So it would require the design engineers who sit there, who work on softwares like um, Altium or a few of the softwares into a place where they would be able to design a very complex PCBs, and also they will ensure all the components are done and put in a right way. Where again, there are electromagnetic compliances for all these things. They have to keep all the systems going well. That's an hardware design point of it. And the embedded coding point of it, imagine like you would have millions lines of code which is sitting inside these controllers and to operate, right? Because the motor is like, let's say, switching at 1,000, 2,000, 3,000, 4,000 RPMs, and then the controller is switching much more higher than that. So you would have enormous amount of challenging situations to control and then test it. So you microcontroller selection and coding of these microcontrollers. And nowadays you have, which I mentioned very wisely, which is here, then the software in the loop, model in the loop, hardware in the loop. right? So because if I talk to my friends who are studying in universities in Germany or in US, so actually they're doing all these things already. Even as a part of engineering which they're studying, they're actually getting hands-on work. If I have to quote it right now, this is a data I got it from one of the college in US. Okay, so they have done all these studies by taking a vehicle and studying these vehicles. It's a team of students and faculties and researchers, and also some consultants from the industry who has done all these images. Even the images which I put it from here is shared it to me by my friend that to share it across, because they are doing all these things already, and they're in MS students. And then on the embedded side, where you say, okay, coding part of the controllers, right? So we would have used few controllers like 8051 or a few other controllers and things like that. But today, industry is using way different of controllers, and because these systems requires a very high level of safety, so you would have something like an ACLD which comes into it, and there are a lot of software processes and things into a place. Let's say there's a standard called ASPICE, there's a standard called AutoSAR and things like that. So on the other side, the testing and the hardware of it, hardware side of testing of the hardware and testing of the software, and then the calibration of all these components, then communication stacks, and which is said software in the loop or a model in the loop or a hardware in the loop type of testing. And then if you talk about a thermals, that's about again a mechanical engineering perspective of it, because you're converting energies from different voltages to different voltages. You have very high amount of heat being put out by your IGBTs or let's say MOSFETs in switching to these higher frequencies. So you need to cool all of these components, right? Or else if you do not do them, they'll burn out or their efficiency will be very bad in different regions. So we need mechanical engineers in involving the thermal side of the traction inverters. So if you see overall point of it, there is a huge scope for electronic engineers. That is a very important factor to understand from an electronics perspective of it. And also on the electrical perspective of it, there are a lot of power electronics which you study in requirements. Communication side of it, you guys study from the communication side of it. The only thing is, okay, you study, but how much is which is very relevant to an industry side is that's the only question which is out there. Then on the EV chargers. Okay, so before we go to EV chargers, let me just take a few questions here so that we can just see through how best we can answer them. So guys, if you have any questions in the meantime, you can just drop me a question here. I'll try to see through how best I can answer them. Okay, is mechatronics is good for courses on EV industry? Yeah, Vineet, I think it is more relevant to EV sector. So you would study about more about controllers and actuators, things like that. Yeah, I would say it is a bit more relevant and more related to, I would say, an EV side of it. Not say everything is EV, but yeah, side of EV is a part of it. What is the basic need to go in EV sector from electrical engineering perspective? I think I'm trying to define that through my presentations. Possibly, yeah, we could take this up, Sharon. And how many electric two-wheeler startups can survive after COVID? Jay, I think I think from my perspective, the friends I'm speaking to, I don't know anybody will just collapse. Okay, and it's not something like a recession sort of a thing, but yeah, there is a small market correction. We would see, as predicted with a lot of people who I interact with industry, yeah, expensive segments of EVs will go a little high, little get affected. But on the lower side of the cost, people are would like to adopt EVs, and all the commercial requirements people are looking forward. Possibly when a customer buys a one bike, right? But if you go to a Zoom car, let's say you go to somebody like a Big Basket or Grofers or Amazon or a Flipkart, see they buy like 1,000, 5,000, 10,000 vehicles, and they see a more meaningful sense because it saves a lot of, because buying an IC engine would cost them, like the operating cost of IC engine is very high compared to what we have in EV. So they would definitely prefer for it. Maybe it's a very sort of sensitive question to answer, but I would say, yeah, I see positive way of industry moving better after COVID too. COVID is not something like an economic recession which has happened. Things have collapsed very badly. I think things are in shape, and people have orders. People procure components, and people have plans. They have money in the back, and I don't know if something is really affected that badly, but yeah, I see still. So can mechanical engineering student can also work in EV companies, and what are their job roles? Absolutely, Gaurav. There is a huge component in mechanical engineers, which I was explaining about design, thermal. And if you see on the other side, I want to address the mechanical engineering side, because every college or students I interact with, they say what is there for engineers, mechanical engineers, and things like that. Guys, wheels are wheels,
Though
seats.
our signs are not yet done, I have mailed to them.
So if you see the vehicle chassis are same, seats are same, doors are same. See, guys, I worked with Mercedes for a while. I used to design automotive plastics. See, I don't know if electric car doesn't have a bumper, right? It still have a bumper. You know, it all the dashboard components and everything is still damn there in the electric car, electric bike, right? So I don't know. Just the powertrain is changed. I totally agree, but doesn't mean that mechanical engineers will do the job just because it's an electric vehicle. The powertrain is getting replaced, but I'm showing you you do have an importance because all these casings, cooling systems, components, connectors. See if I can, because I was an engineer even at Chrysler in US too. So we used to work on all these things. That's what amazes me because we don't get that exposure in the college. See, you take this connector which sits here, right? The white color connector. You take any of this connector, couplers. Who designs this? We are the mechanical, like, okay, so I would say mechanical engineers design it because it's sort of a passionate question to answer, right? So you need engineers. There is no way these all things could be done by an electronics engineer, but definitely without them, we don't do any other components into our place. So we need them definitely. There is a job roles for Gaurav. It may not be like you would do a magnetism in let's say the motors, but yeah, you would definitely do other side of motors. Let's say because more number of motors has to be manufactured, so it needs a design iterations and things like that. You will work there. You will work in thermal side of a motors, and possibly you're working in thermal side of engines. You're going to work on thermal side of motors also. Sorry, I might have taken that question a little personally. So, but yeah, don't feel bad. But yeah, see, the cars have doors, cars have seats, and like that you need to understand. There are people who design the same thing. So, what skill sets are expected for a mechanical engineer in EV? Okay, guys, at a system point of it, I would answer it back to you. At the last, I have a slide where I could answer to you, Moto E4. So, Rishabh, I am a mechanical engineering student. I think, yeah, I would have answered to you. Maybe personally, I can answer to you a little later. I'm a QC, quality control electrical engineer, 13 years of experience. Any chance to change job into EV field? I think definitely there are opportunities, Sudhakar, in your own side. You see, because it's just like a traction application of motors, controllers, DC-DC converters, and all these things. I think yeah, production is increasing. Companies like Bosch and all these people are looking for volumes in the future, and there are some startups also coming in. Maybe we could look potentially in that area. Ajay, where is the best place for learning EV technology with placements? Ajay, definitely, it's a good question. I would say I'm not very skeptical about it. Decibels and Stumag is coming up with amazing courses at the best lowest possible prices that nobody is able to give that kind of a quality with kind of an industry based curriculum and content. So we could help it to you, and definitely we will share it across to you if you're interested to take it ahead. In upcoming years, for all electric vehicles, which get more electrical engines or petrol engines, I would say like it's more toward electrification than a hybrids, Hemant. And what you can say about a huge competition in the Indian EV market? I would say there is no much competition still, Jay. If you see, it's a very less people still, okay, because the amount of volume we have for sales, I think we still not have enough companies to manufacture. We don't have enough ecosystem still. I would say it's not a competition at all. So I think there are more companies to come, more bigger player to come in. I would say that is going to happen. So I'm a student I'm an engineering student. Can I get kind of internship for a EV training in EV sector? Definitely, Rishabh. We will definitely help you out on that. So I'm Nikhil from okay ENC. All right, guys. I think I'll pause the questions. You're wonderful. There are a lot of questions. I'm fascinated to answer these questions. But yeah, I will go back and finish my part of the slide. So maybe we can, because I'm not sure everybody is interested to hear to these answers. So that I'll continue my session and then I would answer these questions. I believe it's that okay for you, right? We have stopped at Nikhil's question. We will take a Siddharth's question going down the line. So yeah, in EV chargers, if you take, so now let me go back and kind of put across where we started, right? So we started here, right? We started with a motor. Again, guys, transmission, who designs? There is an opportunity for mechanical engineers. So the motors you have, then your inverter we spoke about. So motor is the driving part of it. Inverter is a device which actually takes the DC, converts to AC, supplies the motor. That's an inverter, and also it controls so much of functionality inside the motor, right? That's about inverter. So we talk about charger, which is right here, onboard chargers. So yeah, if you have any applications drawings, please just openly drop it to me. I don't mind accepting them, right? So so yeah, in terms of EV chargers, again, you see it's a similarity of motor controllers, right? But here you do, let's say you in your house you have you got an AC current, but your battery need to be charged with a DC. So you need a device which converts that AC into a DC, right? That's one of the very simplest functionalities which I could say. Then on the other side, again, there are a lot of different control approaches, control methods to charge an EV. That's what comes in depth about these components. It's a pretty much similar to the areas of what we see in motor controllers. Again, the motor controller would do a functionality like converting a DC to, let's say, AC. And again, on the other side, when the motor is functioning as a generator, you would convert the motor controller. Again, has a part of it. It becomes in converting your AC coming out of the motor into the batteries, right? So it's a regenerative part of the motor operation. On the chargers, yeah, you get an AC current from the socket. So you need to convert that AC. Let's say you're getting around 220 volts, right? A simple socket would be around 5 to 6 amps, and then the AH socket will be around 16 amps. So you need to step down that and put it into the battery, right? So how do you do it? You need to go through all of these components and put it in the right place, that there's a right conversion happening. Again, if you see, there are a lot of fluctuations in the source, and you need to filter out all these things. Then again, there is a harmonization issues and things like that. So you need to put all these things. I mean, maybe from an electrical perspective, you could understand better. So that is about, guys, for on the side of electricals. You could see the importance of your subjects, your own applications, what is there in EV chargers. It's majorly power electronics and also the controllers, which will help us in terms of properly maintaining the systems at the right time. So yeah, I would say it is a combination of an electrical engineer and an electronic and communication engineer, and also a bit for the mechanical engineer. So you could see, because this systems goes at a very high temperatures after switching, because you have choppers and all these things inside, and IGBTs and MOSFETs. Again, they heat up in switching out between the different loads, so that you need an enormous amount of cooling for all this system. That's what you see in the right hand top corner of the screen, where you got a cooling system for these chargers. Okay, so on the other side, you can see the roles and responsibilities. See, I'm not defining a job role here, but this is sort of a domain where there's a requirement. Power electronics, again, same hardware design, embedded coding, so testing on hardware, calibration, communication stacks, and SIL, MIL, and HIL. There is an upcoming course on a webinar, on a free webinar on a SIL, MIL, and HIL. You can take part to understand what is this thing. If you know something on these things, there is a huge importance. See, guys, it's very simple. Everybody have engineering degree, but people in industry are looking to have a very specific skill. Okay, if you have a better skill than somebody else, and people are actually, if you ask me, I can't refer a lot of people, because I get a lot of resumes, but I don't see any skill sets on the resume. That's what we're trying to emphasize. There are opportunities. We just need better engineers in the market. So going ahead, we would jump into traction batteries. So the battery, yeah, you would know from the excitement point of it that it is the major source of energy, which is for the vehicle, right? And the damn thing is, it is a most expensive thing in the EV, right? So it's both. It's sort of a seesaw. So it's good, and again, on the other side, it is challenging, because if you want to replace something goes wrong with the battery, you are replacing an expensive component of the whole vehicle. That would put a lot of tremendous cost on the manufacturer. If you want to do something wrong with it, so he has to be, or the company has to be, very, very, very careful about selecting the cells. And selecting a cell for automotive is just not like selecting a cell for a drone application, or let's say the toy application, or a very simple UPS application, because lithium-ion cells are also used in batteries of UPS, your mobile phones and things like that, right? But in automotive, again, as I said, the motor undergoes a enormous amount of transit currents and torques and things like that. The same way, the battery, who supplies the current to the motors? The battery supplies, right? So again, the battery will undergo a huge amount of ups and downs. So you need a cell which is capable of handling, I would say, cell chemistry. There are the specific cell chemistries for automotive application. Again, on the side of it, we need electrochemistry engineers. So that comes where a requirement of an electrochemist. So where they work on the creation of an anode and a cathode, or materials for the anode, materials for the cathode, separators and electrolytes, and ensuring that the cell doesn't go bad in higher temperatures. It doesn't go bad after a long time of utilization and things like that. Imagine, you're using your phones, right? You have a OnePlus phone. Let's say they tell, okay, you can do a fast charging within like 30 minutes or 40 minutes. You keep doing a fast charging, after 2-3 months, you could not even find a better battery backup in your computer, then so in your phone. Then what do? You just go and drop this thing onto his face and tell that, I brought this phone paying this much of money, what the hell you are giving me, right? The same thing here also in automotive, and here at least you have one battery, right? It's a very simple one. You can just replace it for the cost of, let's say, 2,000, 3,000 rupees, depending upon the type of battery. But if you go to an automotive application, guys, it costs like anywhere, if it's a four-wheeler application, at least around 2.5 lakhs, up to anywhere up to 30 lakhs, if it's the application like a Tesla, right? So when you can't take a risk of just replacing a battery, and you can't just replace one single cell. Okay, tell, okay, there are 7,000 cells in Tesla Model S. You can't just find one cell and replace its cell. It's a lot of complications into a place. So we need a lot of engineers working on electrochemistry side of it. Cell simulations, where we use a very advanced simulation tools, Cosmol, MATLAB, and other tools to understand the functional behavior. And then the pack simulations. Now you have a cell, and cell behaves in a different way when it is individually. But when you connect to a pack, because there are interrelationship between the pack and the cell and the other component, the whole thing's in pack, that can go in a different way. So you need engineers working on a pack simulations and cell testing, cell thermals. Basically, it's a temperature of cell and distribution of the temperatures in the pack. That's basically the pack thermals and a pack design. So again, if you consider the whole pack, which is right sits here, right? Imagine if the vehicle met with an accident, right? And then if one cell blows up, and it is basically like a one big bomb sitting inside a car, right? So you need to ensure that the whole mechanical design safing is properly done. And on the other side, basically, it's not about coming to that level. You need safety systems within the cell itself, that the cell can blow up if something goes wrong, so that it doesn't affect the rest of the cells, or else at least there's a fuse in the system, and there are things like that. So that becomes a very mature topic of discussion. Again, overall, if you say a pack level, there are a lot of mechanical aspects of it, in making it, and the chemical sides of it, right? So this is what I would put it as a battery pack side of it. So there are a lot of requirements for the engineers, right? So then on the other side, there's a battery management system. So what is battery management system? It's sort of a hardware and a software. You see right here, it's a hardware, it's embedded systems, right? And a software too, which is a meaningful sense of it that ensures that the battery always kept at its own safety regions. Okay, so that's the functionality of a battery management system. It ensures the battery doesn't go into out of this safe operating areas. That's the functional requirement of a battery management system. Today, every lithium-ion battery requires a battery management system. So it means that every vehicle you're releasing, there is a battery management system inside that, the vehicle itself, right? So that again requires and demands the engineering skills, that you need to have a knowledge of, let's say, cell characteristics and cell behavior at different times. Imagine, I could tell you a small example. If you keep using your phone, always play, let's say, some games, internet games and things like that, your battery would go bad very soon. Or take an application like automotive, you just keep accelerating your vehicle too faster whenever you drive, it'll affect the battery life. And the temperature of the environment also affects the battery life. You drive the vehicle, when the electric vehicle at a temperature like 45 degrees Celsius, you drive the same electric vehicle at a temperature like 25 degrees Celsius. If it's not thermal, there is a thermal protection inside a pack. There is no like a forced thermals. Then the vehicle will give you lesser mileage. So like this, there are so many parameters we will understand about before you design an electric vehicle. That requires a lot of engineers again to study these cells, right? So we have a cell testing equipment where we put a cell. Every company today, you take in companies like Ather and everybody, I have like huge number of engineers in the cell testing area. Not only at a cell level, at a pack level. Then you put a pack into the vehicle, you take it to a test track. They don't do a test track like 10 days, 20 days and all. They do testing for like years. Maybe like 2 years is something like I would say the minimum development for one segment of a powertrain. So when you have to do all these things, you need engineers. Like, where do we learn all these things about in college? To design components and test the cells. But where the facility even we have at places where we can study all these things, right? So this is what I see, because if I see all these things at somewhere like in US, like University of Colorado and all these things, they're teaching all these subjects way back in 2013, and that just wonders me about talking about drives it way back in 2013, right? So we still have a curriculum which has been updated as of today. So yeah, keeping it a part of it. So battery management system would require engineers from a side of everything, a chemical side, electrical side, electronic side, a mechanical side, and also we need some engineers from an area of artificial intelligence and machine learning, because these cells are so complex that they're behaving in its own different ways. So it is with respect to temperature, that with respect to environmental condition, with respect to the way you use the battery, with respect to its chemistry, with respect to a lot of its conditions, the battery is making its own different meaningful sense for it can only understand. But we need engineers, let's say, have a artificial intelligence or a machine learning, where you could predict the future of battery. Okay, how much it can store, how much it can give out as a power and things like that. So there are a lot of people working on a AI side of it, for guys who are from the computer side background. There are opportunities for you guys also in the areas of the battery management system, maybe which I could not cover up some areas like a telematics, IoT in automotive, right? So there are applications like this, because today we can talk to the vehicle you just using your phone. Maybe you're in your home, you're just finishing up your breakfast. You can just open up your mobile phone, open an app, and tell that, okay, turn on the air conditioning system. Before I go, the car will be like at ambient temperature. And right, the things like this, you can check your phone inside your phone, and then what is the battery SOC and things like that. And all these things requires a telematics, right? It requires a cloud, sort of an IoT thing, and stuff like that. So there are a lot of people who are working on these areas also from the computer science background. So yeah, as talking to related to BMS, this is all things which is as a role of an engineer. Damn thing, right? So this is a lot of things about what all we can get, and I think what I just covered is a pinch of salt in a sea, maybe I would say. But it requires you to have a good amount of skills, good amount of knowledge. But if you ask me, engineers are required in the EV segment. So yeah, it just requires skill sets, okay, competitive skill sets to have to start a career. So cool. That's a bit about technical side. And if you ask me, what should I learn to get prepared? I'm sorry if somebody felt it well offensive. It was just to kind of make it a bit of a funny thing and a bit of a bit deep technical talk. So what should I learn and get prepared? So yeah, one thing is you should have a knowledge at a EV system level, not just knowing, okay, there is a battery, there is a motor, okay, there is a controller, blah 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 blah. It is every kid knows today. You believe me or not, when I conduct some training programs, I get kids from 7th grade and 8th grade, and they talk like, I want to learn about BMS. I was like, dude, are you serious? I mean, when I was your age, I did not even know what is electric vehicle, right? So I can see the serious sense in even kids too, right? And these things are there in internet, and they study, they see through YouTubes and stuff like that. So like everybody knows, like, what is BMS, okay, a few things about two lines, but we are engineers, right? So we just don't want to know it at that level, and we just not news reading it. So it requires you to have a very deep knowledge about a system as an EV. And when I mean a system, okay, go in deeper, understand how they behave, why component selection is like this, the system rating is like this. What does it make a sense? What kind of controllers they have used inside? What is it like? Sort of a testing systems they have done, what kind of validations they were there, and things like that. That is what it requires when you say EV at a system level. And at a subsystem level, go deeper, and then you can derive, okay, if I take this motor, how was it sized? What components are there inside this motor, and why did they go for this kind of a motor selection? And maybe what kind of thermals this motor is running at. Okay, let me check. Okay, if this motor have this graph, where is the efficiency plot and it is operating in this region, right? That is what we study at a subsystem level. And choose a specialization. See, first thing is to understand a topic, and get a foundation. And I don't suggest you guys to take up, let's say, because Decibels also offers a masterclass where it is equivalent to 1 year experienced engineer. So, but I won't suggest you possibly at the beginning. First, you understand, okay, what is all about EVs, what comes in EVs, and where do I fit first, right? Because that's what we do majorly. When I took my engineering, take mechanical engineering. After I took it, I understood there's so much about it. I didn't know when I graduated what to do really, right? I think it's just the same for most of the students. I know because I just graduated as a mechanical engineer in 2012. So all my friends were in the same situation, right? So it is just like that. Don't fall into the traps. Don't just take a course randomly and it guides you in another direction. It requires a structured learning. Okay, the main of a structured learning is you should have a step-by-step approach. Okay, I learn the system first, I learn the subsystem, later the subsystem, then I choose my specialization, then I'll work in that specialization, right? That is what it requires. You say specialize, you require, or let's say the industry also requires specialization. I'm not telling that you could take an MTech, because there is no. I would not say there is a proper MTech degree available as such. You could do it in specialization in EVs as such. right? So maybe you could take up with sort of a very good industry mentor and something like that. You could be able to study and I get right guidance from the industry expert. That's very important because you learn something, then it will be outdated or something of that sort, or else it's not really like where you can get a job. Because if you ask me back 2008, 10, 11, I was looking at hybrid vehicles at that time at my college days. And when I graduated, there is no damn company who was working in India about hybrids. Maybe there were a few people who were working in hybrids very confidentially. So I was not able to get a job. There's no even interview I could get and attend it, right? So you should be very optimistic in terms of which domain I can select. That is only possible when you understand EV as a system and then they go to subsystems and things like that. Then carry out projects. This is a very important thing. I don't know, there are students out here, industry people and things like that. You guys, nobody cares what degree and graduation you have. If somebody comes to my company for an interview, I say what have you done? Because theory is wonderful, it's really great. I also studied in my engineering, but what projects have you done? What deeper you've gone into understanding the engineering? Did you just buy a few components and assemble them and it's just, yeah, this is a project? But it's not like that, right? It's more about, okay, what tools did you use? What development board did you use? Okay, is this something our industry is also using? That's what I ask with people when they come to the interviews. So that is what is required. So carry out projects. If it is very expensive for you, you can do simulation projects at least. Okay, that's what even universities like in US and Germany are teaching today, right? They use it through MATLAB, they use it through Scilab, and they teach to students in doing tools and developing modeling of these systems like a motor, controller, DC-DC converter, things like that. So you could also do them and in the proper guidance and stuff like that. And then build some simple solutions. Maybe just a very simple one, right, as a project. And be aware of what tools are used in industry. That is very important, right? Because you say, I know Arduino. Like, goddamn, anybody cares about Arduino in industry side, right? And that too in automotive, we have ASIL, we have very specific standards in an automotive. They don't even qualify for any of these standards. Okay, they talk very specific to an application like an automotive. So you need to be aware about which specifics in automotive if you want to be in automotive. And then start with the internship. Get an internship. Don't expect Tamil to pay you. Maybe I start with somewhere, right? So if at least if it is not available and a paid, at least there are internships available where you could just as a training you could pay and attend it. You can try them and just ensure that you pick a best one, because you're spending your valuable time. I would say money is a goddamn thing you can always get back, okay? But the thing is your valuable time. So ensure that you're selecting a right company where you could just pay and learn, right? So that is a very important thing. And then get mentorship. If you can connect to LinkedIn, few people in LinkedIn, are there a lot of documents available from fine universities. You can go there, you can attend, you can take the classes, and you can refer them and have one guide who can actually give you a proper direction, right? We always say, right, as a guru is required for a direction. So it's like that. Okay, you were doing something, they can tell you, okay, work on this, work on this, work on this. So it becomes easier path for you rather than just going through a lot of sort of a maze run and stuff like that. That's what I could suggest you. So as a part of it, in partnership with StuMag, we are offering, I would say, not as a course, it's an internship. Okay, it's a remote internship, remote online internship. We are offering to students across the country. So in COVID, and everybody knows that it is not possible to attend. And let me just small corrections here. It is not 12 hours. It's basically 20 hours. So this is what you get as a whole part of it. Okay, maybe depending upon your interest, you just want to explore basics of it. Okay, that you could take it up here, and you would complete a basic course. Or let's say I want to go a little deeper, and because you would just understand the very fundamentals in this section of it, and here you take a hands-on project, build a model of the electric vehicle in a simulation tool like Scilab. You'd be able to study the deeper understanding of a motor, deeper understanding of batteries into a place, and understand all the subsystems of EV. And something like this will help you to go through a very deep multiple projects on all the areas of EV. Let's say on the modeling of an electric vehicle, the cell side, and a BMS side, and the battery pack side, and also where you'll be able to work more on the motor controller side and a motor side. There are multiple projects which you can take up and specialize yourself in the areas of EV. This is sort of, I would say, a kind of a foundation for somebody who would want to sort of explore things in EV. That's what StuMag and Decibels are offering. And definitely, it's a great thing from STUMAG to offer a scholarship. So you can apply a coupon code, and the STUMAG will share you across the link for registration. If you're interested to do it and know more about it, you can connect back to us. We can share you the details. So the registration link will be shared by STUMAG, so you can apply the coupon and you should be able to get ahead and register. We don't take too many people for a batch, even though we would earn less, but we would do honesty for the quality of teaching. We would be able to do it. So the batch size would be limited to very specific numbers. So if you're interested, you could definitely take up these things and look forward to participate. And we can 100% promise you that what you learn from Decibels as a team, it would definitely be worth more than anybody. Because today we have every weekend we have batches. We are teaching people from industry, and we just had amazing appreciations on kind of knowledge we are giving to them, and they're looking forward to take up higher courses. So yeah, you could trust as better than anybody else, and kind of prices with which we could offer. There could be a course which is not really worth of what you could pay for. I would promise you the best out of quality, because I'm the course director who will be ensuring the quality of course, and I would control it from end to end in terms of quality. So as much of it promised here, you would be able to definitely learn that kind of an access. There's small corrections inside this, so we should be able to give it across, and STUMAG will share it across the team from STUMAG will share it across the registration links for you. So I think that's pretty much from my side what I could take it across. So now the discussion is open for QA. Let's take some questions from the chat box, and we'll try to answer those questions. Wow, there are 75 questions. Maybe 1 minute each question will take another 1.5 hours. All right. I am glad. I would try to answer everything. Yeah, so that's pretty much from the technical delivery point of it, guys. So I believe I made my honest efforts to give you the knowledge which I have in terms of knowing about EVs. But definitely these discussions on a QA sometimes are worth more than what my technical delivery is all about. But you could wait to answer these questions, like you can listen to the answers. Yeah, if not, yeah, we would just share it across things to you, so you should be able to leave the sessions too. So thank you very much for your time, who guys who are leaving, who are planning to leave. I appreciate your valuable time in attending the session, and we look forward to connect with you. Decibels and STUMAG will be offering a lot of webinars to get more insights about components in EV. You could definitely participate and ask more questions if you're interested. Take it up. Okay, so that's a bit about what is about EVs and things like that for now. And let me go back and take the questions. So, all right. So let me start with Siddharth. Give me a second, guys. I'll just take a sip of water. What extra do mechanical engineers need to learn about EVs? So yeah, I think the question answer to you here, back Siddharth. So first you start with knowing the systems of EV, okay, and then understand deeper about the system, know them better, in be able to understand these things. What is this deep about batteries, and what kind of cell is it, what chemistries are they, and how do they behave, how do they interact, and you have cell test data and things like that. That is something which you can learn deeper, and you could do a modeling of the cells. You could do a modeling of the pack, could do a modeling of the whole BMS and things like that. You should be able to learn and explore more on that. So, sir, I'm a engineering student. So can I get a kind internship on EV? Okay, I think I answered your question, what we are doing along with partnership with STUMAG. So definitely it's a wonderful effort, what STUMAG, and we are trying to put it across. So you could take up those opportunities. Okay, how can I send you, how can you send me this video in email? Shubham, this email will be very big because the email size is only 25 MB. Max, we can put it in the email. So what I'll do is I will be able to, we are recording this video, we'll put it into a YouTube channel. I'll share the YouTube channel to you, so you should be able to go and watch it. We'll be sending you a link possibly, okay? And Tumak team will send you the links to you, don't worry. Jagdish, hello sir, I'm a third year student work on hybrid vehicles, and we almost reached technical readiness for level 5 represents our model in front of the national, but we're looking for an opportunity and a platform. Would like to suggest me. I think Jagdish, maybe you could just drop me a personal text. Maybe the details are here at the last. And I think right in the bottom corner, you have my email address if you want to reach me out personally. So you can just share me more details. Maybe I could see through it and I can come back to you. It's suraj@decibelslab.com. I mean, yeah, give me some time, guys, maybe to respond back, because I get like 50, 60 emails a day. So I would have to take some time to reply back. So yeah, as we said, Nala, so there's a courses online. Can you please share the video? Okay, we could do that, as we said. Um, will you get a good online course like edX? So yeah, guys, I think edX courses are great, but the thing is, like, they're bits and pieces, and also, like, they would use some tools, maybe you not be able to follow it up and things like that, where you just can do it if you can do a self studies and stuff like that. Okay, so Jagdish, uh, okay, right. So okay, what is the future of battery technology? Is lithium will lead the market? Gaurav, I think I am expecting it to happen, because what we see in automotive or any applications which is very stringent, we don't just utilize a battery out of a lab. Okay, this has to be proven technology. Then is the only possibility that we could be able to use this battery tech to a automotive application. It has to be tested, proven for years, then only we will use it, because automotive cannot take beatings what other industries can take. If you have a fridge or a refrigerator, you can just go and tell, okay, boss, repair it, but it is not an automotive like that. So people have invented many. I know there's a sort of a everyday news will come, okay, somebody has invented the air battery, aluminum battery, and all these things. It's great, this is all R&D and lab, but yeah, it takes a while for all these things to commercialize. It requires a lot of testings, approvals. OEM will go through a lot of things to approve something. It takes a while, but I think I can bet right now on what I can tell as future is, at least for right now, I would say that it's lithium for a few more years. Are you providing e-certificate for this webinar? I don't know, honestly. I would have to check with the Sumac team. We can come across. But guys, attending a webinar, you just get a knowledge. It's a information. Don't please expect, because I know a lot of people ask me, can you provide a certificate? But I don't say, okay, I can't tell you you're certified as attended this webinar. But it's just information, right? So I don't know. I could really give it from my side. So, but yeah, we could just check. NVH is noise, vibration, and harshness. So it's more about studying the behavior of a vibration, and how it affects the systems and things like that. What about charging stations and charging time? See, I mean, yeah, there are people. Government is putting efforts. There, let's say, private companies are coming in. They're pumping out a lot of money. Uh, like you would know about this HP and Indian Oil, all these people, right? They're also investing a lot of money, and they're trying to start the what I say as a charging stations, like how there are petrol stations. But so far, I don't see a challenge, because when we have petrol vehicles, it took a while, right? So to adopt this charging infrastructure, but definitely I see tech is sort of ready to current needs, at least to basically satisfy. But yeah, ABB has developed wonderful charging standards and charging equipment. I see there's a lot of possibility what is there, but yeah, tech is not a challenge. There's a financially, what is a commercial viability, because as a business I always see, okay, if I investing on a 10 charging stations, how much money I can make, because you don't have enough vehicles. It's egg and chicken. But if you ask me, tech is ready. So Harsh, yeah, we can do that, Harsh, for the recordings. Vehicle noise, okay. If possible, please share the company name, individuals. Nirna, yeah, it was more about Nissan Leaf, if I can answer you a question in a very bare way. Nirav. Yeah, what subject of mechanical engineering you have to study extra to get a job in sector? I might have possibly briefed you out. Okay, thermals is something really important, and I think more about today as just as a core mechanical engineer. I think everybody has to become more. I would say the multi-domain knowledge guy. So who knows about electronics, who know about mechatronics, who know about a bit of coding. So like we can't be just a core engineers in one area, right? People are expecting you to be a multi-domain specialist. So I would request you just also tack in a few more areas to you. I would say I think I don't know whether your college has a simulation tools like MATLAB or a Scilab. I think that's very important for anybody out here who is an engineering guy who's looking for a job. Guys, I don't know whether it directly helps you or not, but MATLAB is something, or Scilab is something which you have to learn. Don't learn because you have in your college. I know how much practice everybody I had in my college too. So don't go just by a few manuals and I say I know MATLAB. There is a lot about MATLAB which people have to learn. So get maybe the Decibels also teaches courses along with Stumag. On when you take up these courses, actually we are teaching you Scilab and MATLAB for the specific applications. If you take advanced course, and the basic course we're teaching you, MATLAB will be taught in advanced courses. Yeah, why only traction motors? I don't understand the question, Harsh. So, what about subject that we need to give more concentration related to EV? Uh, maybe I don't know. Maybe I would, guys. I would have to kind of come up with. If I record all this session, I get all these questions. Okay, I would do one thing. I'll put up all these questions. Maybe I'll come up with another webinar, just to maybe a live session to answer, personally these questions possibly. So, what are we carrying petrol or diesel long drives? But how could we carry electric? Um, okay, Hemant, we have charging stations coming across. We could be able to use them. Discuss recruitment process. Is there any course we can take? I have addressed that question. Is powertrain course relevant to for mechanical engineer? It is. What powertrain again goes as a deeper question to answer. Okay. So guys, I think if I have answered most of the questions, right? So I don't know. I have answered 87 questions laying around. I think there are very serious people who would like to listen are only there. That's what I could understand. I think people who might have just kind of bailed out, they would have just gone into the meeting. I think if you have any questions, I think you can just unmute yourself and please ask, guys. That would be more easier for us to give it a go. Yeah, kindly please unmute anything and just take one by one, guys, please.
Hello.
Yeah, hi.
Hi. I really enjoyed your webinar. It's very nice.
Pleasure.
Actually, I want to ask how we will be able to make project at home.
Absolutely right question. Yeah. Okay. Any other questions along with it, Gaurav?
No,
Okay.
actually, I see your courses and you mentioned in types means you one project, two projects, and five project. But
Yes.
how we will able to make it?
Perfect. Yeah. So right now, what we are trying to do is we are trying to follow similar guidelines what universities in abroad follows. Okay.
Yes.
We will teach. Let's say you have an electric vehicle. Okay. Electric vehicle will have many components. Let's say there is a battery, there is a motor, controller, and all these things. So the first and foremost thing anybody teaches in them is to model these systems. Okay. So if you are teaching an electric, let's say you take package something which is here. I'm just going to go back. Okay, maybe I would say a plus. Okay, so in that we're going to teach you how to model an electric vehicle in a software like a Scilab, where you'll be able to model a vehicle, where you'll be able to model a battery pack, where you'll be able to model a motor, transmissions, and things like that. So that becomes a project for you. Okay, it is what actually even in industry what people does. Okay, they build models when they work in the segments.
Okay.
So like this, we have done a virtual projects where you'll actually build a whole vehicle model. That would be one of your project. Okay, then if you take a cell, there will be build a model on the cell. If you ask me really how much are these really weightage, it is more than actually doing a real project, because hardware is a cost when you have to build a real project, and nobody would actually build a car and test it, right? They would build a simulation
Yes, sir.
model. That is an objective. Like all the teaching, let's say if you take a basic course where we are teaching you a Scilab, we are teaching you a part of the modeling of a vehicle, not completely. But if you take a plus course where we'll be teaching you, we'll be modeling a complete electric vehicle in a software like a Scilab, and you'll be able to get a deeper insights. Maybe I will send you the link. Okay, maybe you can just go to our website. This one, YouTube channel. I've done another session on EV modeling, webinar on EV modeling. I can share it across. It gives you
Okay.
more value. But yeah, that's the project way. You can do it from your home. There'll be a
Okay.
mentor. They can guide you the step-by-step process. Yeah, Harsh,
Okay.
you want?
Thanks for your time.
Thanks, Gaurav. Thank you very much, Gaurav. Harsh, yeah, Harsh, you're waiting to ask a question.
Yeah, good evening, sir.
Very good.
So, it's been a nice thing. I just have one question.
Yeah, please.
Let's just say if this electric vehicles becomes a reality, I mean to say, let's just say all these motor cars are no more.
Yeah.
So we use only electric cars.
Mm-hmm.
So is it possible to make an electric car which has both a generator as well as inverter? I mean, consider the combination of solar and this battery technology as well. Because sometimes we get run out of fuel on our petrol cars or diesel cars, and we just stack up in those queues and petrol bunks or all. So it's not possible to set up a charging station every 1 kilometer or 2 kilometers as such. So can there be a chance where the car, while driving itself, can we produce electricity for the car, and in terms we can run the car at the same time? Is it actually possible?
Question is good. With the fundamentals of physics, energy can either be created or be destroyed, right? It can be converted from one form to another form. So basically, the battery is a source of energy. You're storing it and you're utilizing it. So yeah, but if you ask me, it is possible that in few ways. Let's say you have a regenerative energy, right? When you brake a car, if you have an IC engine, the energy is going in the form of a heat through the brake pads. So when the if you come to an electric vehicle, actually you can convert that energy during the braking into a regenerative energy and store it. If you ask me how much you can store, let's say you're traveling 20 kilometers, okay? Let me take a 10 kilometers. So what we say, we can usually, depending upon the drive cycle, we can recapture on 30%. That is how much you can produce, just if we compare to an IC engine to an electric. But over it, as I said with the basics of physics, so you cannot generate an energy from the same energy. So if you convert, there is a conversion losses. Let's say for an example, when you use a battery, you convert an electricity to a chemical energy, right? When you're charging a battery, you're converting electrical energy to chemical energy. When you're using it in a motor, you're converting an chemical energy into an electrical energy back again. So there's a conversion losses, right? And again, at a motor, you're converting that into a mechanical energy to electrical energy. So there are conversion losses. Then driver losses are the tires and things like that, right? So there are conversion losses. It's not possible something you can just it's not a perpetual motion machine. Or you can put a solar cells over the top of it. I showed you a sono motors now, in the beginning of the session. So if you go to that company name, you can just type in sono motors, which is in the here. They have put a solar cells on the whole of the car, and they're trying to recapture the energy. They've been successfully doing it. It's sort of a plastic sort of a thing, which is there. Okay, so I think that's what I can give you an answer for that.
Okay, sir. Sir, and one more thing.
Yeah.
Now, I read in some Korean journal, as it says, those people, when we drive cars over those roads, the eddy currents which are produced by the friction are being used as some additional power to the batteries which are being used. Can that be possible on Indian roads as well?
I don't know. Maybe share it across. I'll check and reply back to you. Okay.
Sure, sir. Thank you. Thank you very much.
Thank you very much. Guys, anybody else waiting for the questions? Yeah, there was a question from Jay Pandey. You're pursuing BSc in physics. I think if you are pursuing BSc in physics, Jay, maybe just drop me an email. I'm also looking for some interns. Okay, so yeah, but yeah, be sure you know some tools and things like that. But I'm really looking for somebody who know very good in physics, very good in mathematics. I am looking for people. Okay, maybe it's just an open statement for few people here who are very seriously about EVs. So yeah, I'm looking for some people who to work in my company. I can hire some interns if you're very serious about taking it up. Do drop me. You have my email address, suraj@decibelslab.com. So maybe let me know if you are interested. Yeah, but yeah, it's not something directly, but yeah, I would be very happy to know what deeper you know about things, and maybe you would be interested to hire you. Please send me the recording. Okay, thank you. Guys, anybody else, please questions, unmute yourself. You can ask. Okay. Go ahead, guys.
Yeah, sir.
Yeah.
Sir, Stagma is offering course for 5 months access course, sir. Yeah, after that, can we get good knowledge in electric vehicles?
I'm sorry, your voice broke out. Could you please repeat?
Yeah, sir. Stagma is actually offering a 5 months course or a 2 months course like that, as I shown.
Okay.
The course.
Right. Hey, Shiva, I'm really sorry. Your voice just broke out, and I wasn't able to hear anything. Can you just drop a text, please? Okay, please.
Sir, is it audible now?
Little better.
Yes, Stagma, as you said, Stagma is offering a 5 months course with 5999. after that, can we get a good knowledge in electric vehicles, and what is the process further?
Right. So absolutely, you get
Yeah,
a knowledge which is,
I don't have any idea, sir. Actually, I have seen this your website, and please solve my questions.
okay, yeah, sure. See, sure, definitely, we with the the Plus Pro as we're offering. So it is I would not say like the course will be that long. So basically, it involves your project also along with the course. So in that, what you learn is about all the parts of EV. You will also do a projects about other complete subsystems. So this is something which I can tell you. If I can go back to my couple of slides and tell you, okay, till here, you get a good experience and a knowledge. So where you can learn about all the systems in EV, understand detail of every subsystems in EV. That's what we teach you as a part of the pro course. Where if you apply for an internship, okay, your certificate, your resume would be much more stronger. To I would say even at least much more competitive to anybody else who could apply for that sort of a thing, because you would undergo a projects that gives you a very deep understanding. And maybe I can share you some materials across how we're trying to teach and things like that, and also maybe few feedbacks while people have participated from the industry in attending these courses, how much that been helpful for them. So with attending this, I can promise you that you would have enough confidence about all the components in EV. If we start from basics and then taking to the next level of complete advance. So, but yeah, it requires you enough time, because we also offer a masterclass specialization for people who want to get a jobs and things like that. But until if you take up this course, you would have a very good confidence to attend any interviews for sure.
Sir, after this course, whom we have to approach, sir? Like you are giving certification, like e-certificate, and what is the process further after this course?
Uh, Process for
Further, sir, next step.
so, I mean, if I may know which engineering you're studying right now. You're studying already.
Electrical engineering, sir.
You complete.
Electrical and electronics.
Okay, wonderful. You completed.
No, sir, I'm final year student.
Okay. So once you complete the course, okay. So one thing is definitely we can help you, because there is a sort of a support for career mentorships and things like that. So you can definitely be in touch with us, and we can help you to make. First thing is, we are connected to a lot of companies in here around in Bangalore and also across the cities, because we are situated in Bangalore right now. All the courses are done online as such, and if you're further courses and all, we can also do offline. So yeah, if regarding the completion of the course, you can connect to us. You can be in touch with us, because on the platform you will be always in touch with us. So then once you graduate, you can let us know that you have done this course. We will take your resume, okay, and we will be able to follow it up with share it across to the people in industry.
Yeah, thank you, sir.
Yep, thank you.
Thank you, sir.
Thank you. Anybody else, guys? Any questions? I'm also going to the questions which is in the left side here. Yeah. Guys, please go ahead if you have questions. I'm listening.
Hi. This is Venu, and so I'm working on a startup which is related to tech, and I was always interested in knowing a lot on EV market and all. So I was just having a question. Can you share the challenges you see in coming years in India, probably on the EV markets, and maybe apart from finding quality talent, because I mean that is anyways there.
Yep. Okay. See, I mean, on the side of it, because I don't mind, like, just this is the perspective of myself. So one thing is, okay, as such in India, okay, we are always being about a price sensitive market. So I would say as a concern, but a very sensitive market. So yeah, companies need to be more innovative in terms of their offerings, what they're trying to come up with. And right now we do not have really good products, I would say, which is suitable for the market. A very matured way in the way they are. There may be one or two which I could not just name, because just sort of a thing, not to depreciate somebody else. But yeah, it requires more matured products into the market. That's the first thing at a system level, because we've been a country where tech is not much developed here. Tech get developed in some other country, and then we would become a dumping points for a lot of people. But that's what happened in diesel engines and things like that. Okay, something get over in Europe, that comes to India and stuff like that. But maybe in EVs, okay, we won't be able to follow the same path in the same way. But being price sensitive makes us more competitive to what we want to offer and how we want to build a product. I think in that line of it, yeah. So development as such, you'd see a sort of a more maybe with my predictions that more of a manufacturing also being pushed here, but we still, because if you see, Ather has developed their motors. They used to buy motors from Mahale, a German-based company. Now they have moved to things getting in India itself. That's like a fantastic move, if I can tell you. So it has been, I don't know if I could just share it across. It is co-developed with IIT Chennai. So and maybe manufactured by Bosch. So like you could see these things are happening. So the tech is also getting developed in India, and we still have to import a few things. There is no doubt on that. But people are working in tech, and a few people are identifying things they can do it here. So I see more of manufacturing being localized in the country. That is one direction which I could see, because cost is being a parameter which you have to manage. And I would see only the good players will sustain, because it's our market is always like that, right? Like you rush. A lot of people rush because they have money and there is no direction. There is no things. Maybe like a lot of colleges today, why we have and few will close down. So the same way, maybe a lot of people with things without vision, without things like that, the proper clarity, experience in the industry will jump into the market. They have jumped in already, and this will go down, and you would filter out a lot of people, maybe a few people, because they don't have money and they couldn't find a good market. Even good product is there, they may go out. But yeah, it becomes preliminary that very very good product with a good support of fundings. Like let's say biggies like Hero Motors and all, who funded a big companies, they would sustain it back because they have more beating to take in automotive. Maybe that's the direction which I could think. And that's two-wheelers majorly, which I kind of want to put across. On the four-wheeler side, yeah, I think it is still very sensitive to say volumes in EV because of the price sensitivity. And yeah, I would say range sensitivity, people are there, but I think to bring that awareness itself is a little tough, because people are spending like 20 lakhs and 25 lakhs for the vehicle like the Kona, or if it's a Mahindra, they're spending around like 8 to 10 lakhs. I think, I don't know, it's still very less samples to predict how India would respond back to that. Maybe with the McKinsey reports, which I've been reading, there is sensitive adoption that is going to happen in India too with four-wheelers, but two-wheelers is a good opportunity ahead possibly. And I believe I gave you some insights.
Yeah, of course. Thank you so much, and it was an insightful session. Very happy to be part of it.
I'm pleasure. I am happy you found that time you spend is qualitative. Thank you.
Yep. Thank you.
Pleasure, Kumar. Right. Anybody else, guys? Please go ahead. I am reading the questions on the other side. If I can answer back to you in the meantime. So, how will we make a project? Yeah, I answered your question. You will be making it from home. So yeah, so very nice information on technology and right. Very nice information and latest technology for circuit branches, students and faculty. Thank you. Right, I don't really want to sort of tell that we don't have that curriculum which is available right now at universities. Guys, it is a truth. I don't want anybody to take it wrong way and feel offended. But I'm just like telling things which is going on, because we need better subjects. I think AICT will understand, and local universities will understand and improvise things on that. So can you share some challenges? Okay, I've done it. Yeah, anybody is there, please go ahead. Sandeep, you want to share something?
Good evening, sir. I'm sorry I have joined the meeting so lately.
It's okay. You get a recorded session. Please go ahead, Sandeep.
Sir, I want to know what are the challenges in the electric vehicle batteries, sir, during the charging and discharging?
Okay. So challenges as such, okay, so in terms of India, we see a huge variation in temperature. So that has been a very bad for us in developing the EVs. So I think, yeah, we would have to work very deeper in terms of, because what happens if I can tell you, if there is a 5-degree or a 3-degree variation in the temperature of the pack, it will affect its battery life. So that is one thing which India requires a very serious concern and work on it. First thing, because we don't manufacture any cells in India as of today. As such, there is no localized manufacturing capability. So we're buying cells from Panasonic, or let's say even Samsung or LG, or let's say some other companies, and even local other manufacturers in China. So the thing is, we're not talking about cell manufacturing as of today in India, right? So we're talking about, okay, how I can use a cell and then build a battery pack and then use it for a very specific application. So we sort of think that it's an application engineering, right, rather than a technology development in cells. So that perspective of it, you always talk about application. Okay, how this cell is going to behave at a temperature, how its cell going to behave if I use it like this, how its cell is going to behave for an environmental conditions like this, and how it's going to behave if the user pattern is like this, and maybe how it could behave for let's say a depth of discharge of this type, how it's going to behave if the charging and discharging is happening this way. Maybe some customers, if I can give you an example, they only drive 5 kilometers in a day, right? So when they're charging, and some of the customer is driving 30 kilometers a day, he may be charging every 2 day once. Some customer is driving 45 kilometers in a day, so he will be charging once in a day. So like this is about application point of it, what India is trying to do, what OEMs want to do it today, because there is no cell chemistry development sort of a thing. As I know, at a OEM level, and then wouldn't be bothered about it. They would find a partner and get the cells from them, than just trying to think they can do it. So that's what is going on. So people are talking about that, the perspective as an application challenges, and they're talking about a BMS development, the battery management system development, that the battery can function better, it could function in best way in all the conditions and things like that, and so that we can protect the battery, can increase its life, and things like that. That's what people are doing at OEs, at either some matured startups today in segment of cells. I don't know if I have answered your question, Sandeep.
Okay, absolutely have answered it. Thank you so much, sir.
Pleasure, Sandeep. Thank you. Yeah, guys, any other questions? I'm always here to listen to you. In the meantime, I'm reading the questions. Siddharth, thank you, Siddharth, for your time and being here. Can we build an AEV with both generator, inverter? Okay, I think I answered your question, Harsh. Yeah. So, what is traction battery? Okay, guys, who is Redmi is here? Okay, yeah. So, traction battery, yeah. See, there is a very specific thing. What traction means, a mobility application. Okay, so you're using it in your phone, right? The batteries are being used in phone, so they're not the traction batteries. So are used in UPS applications. They're not traction batteries. Traction battery is a battery which is used for a mobility application. that's the difference of a traction battery. So maybe if I can tell you something, right? You have a battery like lead acid battery in your bike, right? You cannot replace your UPS battery with that. The way the UPS battery behaves is different, and the battery for the your starter motor to work is different, and it's totally different. So that is a difference between traction battery. Okay, what is the upcoming session webinar? We will definitely update you, Shubham, when the sessions are being planned. EV is for heavy vehicles, also like transportation of goods. So yeah, I think heavy applications. Yeah, people are trying to build EVs for applications like a trucks and all. But yeah, they have different tech, like a swappable battery technology. Let's not only talk about, let's say, heavy transport. Yeah, even the transport of people is also like buses, right? They're talking about it. They're trying to have a transit charging, rechargings, and things like that. They're working it out. I think yeah, there is no limitation as such that why we don't do it in the transportation. People are working on it. The ABB, if you see in US and in Germany and all, they have developed some techs for that. Please tell us the environment of entrepreneurship charging. Ananta Bharati, I am really not sort of a tech commercial guy, but I'm not sort of a more towards charging entrepreneurship. I'm really sorry that I don't have that sort of a matured idea about a charging station business model. I think MSME does conduct some programs on for businesses in charging, things like that. I would definitely maybe possibly pass on my question to that kind of a matured sessions. Yeah, can you please drop me an email? Yeah, it's suraj@decibelslab.com. Okay. Yeah, right. So that's pretty much from my side. Yeah. That's the questions. Guys, if anybody is here, you want to share your feedback. How did you feel about the session? Was it really useful? I know it did make a meaningful sense for you to spend some time. Let's say we spent around nearly 1 hour 42 minutes. Wonderful. So if you felt it, yeah, it is good for you. You can just share it to us. If it was like something not right, share it to us. We will always love to improve it. And I'm not a person who would get feel bad about if you say something wrong with me. Please, open to you. Just unmute yourself and share your inputs that we can also improve and learn along with you. Thank you. Yep. Right. What is the role of AI and ML, guys? So there are a lot of things in automotive because system is very complicated. There are a lot of variables when a functioning system is behaving, and that is kind of very complex to predict by, let's say, a set of few governing differential equations, right? So it becomes very difficult to just say, okay, this is my fourth order differential equation, let's just go ahead and solve it, right? So that would be very challenging, and system keeps behaving in a non-linear way over the lifespan. If you take a battery, let me just make this jargon very simple. Let me just take a battery, right? The battery will behave in so many different ways over a lifespan, over its temperature, over its working conditions, over the way you abused it, over the way it has been charged. So it is like you have just not able to make the system linear. It was not functioning in a linear way, right? That is what I would say is challenging for a general set of equations to drive, or a little lookup tables to do it. So, but with using sort of AI and ML, we could just another thing which I can tell you is we don't have enough test data, okay, to just tell, okay, this is how it's going to behave. So we need to let's say in a simple way that we have to predict a future by having a few set of data, right? So that is what I would say that machine learning and AI is used for, so that you have a bunch of data. Using that data, how I can predict behavior of a system, right? That's where AI and ML is being used for. Thank you very much, Jay and Madan Mohan. Is there any option to change existing fuel vehicles to EVs? Conversion of yeah, definitely, Madan. There is something called retrofitment, and there are few already RI approved kits are available for few vehicles. I don't know for everything, but few vehicles it is available. Even for hybrids also, there is some company, I don't know what's the company name. You can just type it in Google. Like, there's a company who built a hybrid conversion kit, so that is also available. You can look for that. Yeah, there is a possibility. I don't know the market way that how much in a business sense, but yeah, there are people who are doing it, and I don't know how is the quality of it, like because OEMs are struggling to set few battery packs in the right way today, but I don't know really if I can just trust a supplier who just give me a battery pack and tell, okay, it's all good, and you don't have to say that trust the testing agency either. So it is challenging, but I don't know, but yeah, if you have a hobby project, yeah, sort of a thing, learn on your own, and I would say, yeah, go ahead. It's a wonderful thing to do. Is there a group discount available? Okay, Gaurav, I don't say it is there, but yeah, because already the features has been offered as best as low, and I'm not sure if it could be there. But yeah, if there is something like a college, the whole college want to take up the internship or something like that, we do offer approaches of group discounts if it's at a college level sort of a thing. Maybe whole college department have to take it, and maybe something of that sort. Okay, maybe you can speak to your college. Maybe at that time we can even sort of think about giving a one vehicle to your college, where you guys can build it, and things like that. So that's my answer, Gaurav. Yeah. So yeah, I'm very surprised. There are a lot of people who are still there listening. I'm very happy for all your patience. I don't know whether you have any questions and things like that. Let me know if any questions are there, and just feel free to ask, and I can answer you back. All right. So yeah, last call, guys. Please, if you have any questions, you can just let me know. If not, I am very thankful for all of you for staying back and listening to the session. It was wonderful, and thanks for asking the questions that made it more interactive and interesting for everybody. Pleasure for all of you being here, and thank you very much for giving me an opportunity to share a few of my knowledge and direction towards EV. And I would say, yeah, the first thing goes back is like I want to see my country being involved in EVs and a lot, and not just engineers coming out of the college and going to US and doing some things. Maybe we can think do better here, right? So yeah, that comes to this point. Yeah, let's see how collaboratively we all can engage ourselves in tech and EV and build things and ahead, and maybe we all can collaboratively do things into a place. And a fantastic audience. Thanks a lot, and thanks for giving me an opportunity. And thank you, Stumag, a lot for making this up and bringing interested people to this whole platform, and fantastic efforts in doing it. Amazing, and thanks a lot, everybody. Just please share your feedbacks. Again, I'm here for a few more minutes and taking a couple of sips of water. So just share your feedbacks if you felt good, if you felt bad, and anything about it, and we will see you in the future. Thank you very much. All right. Yeah, guys, if anybody is interested, maybe if I can tell you, if you're very serious about EVs, maybe I would tell you, pick the last one where you'll get actually a more project to practice. So that becomes actually a more meaningful sense that if you're spending something, you're spending it valuably. So yeah, if you just want to just check out, and I just want to learn something, okay, let's see what is there inside, you can just go for something else. Thank you, Shubham. Yeah, Paninda, the Stumac team will share you the registration links. All right. How can we register? Yeah, Jay, again, as I said, the Stumac team will share you the link for the registration.
Yeah.
So
yes, Suraj, hello.
Hi.
Hi, Suraj. This is Vijay from Stumac's team.
Hey, hi, Vijay.
Hi. Yeah, Suraj, it's a great session. Good, nice to see many people. Yeah.
Wonderful, yeah.
Yeah. Okay, we'll end this session. I'll send this YouTube link by following up with your team
Okay.
To the participants.
Fantastic, yeah.
Yeah. Thanks. Thank you for the session. Thank you, guys.
Thank you.
We'll have a discounts also, group discounts. Everything is offered. You can contact Team Stumac. We are available always.
Yeah. Certainly. Thanks very much for hosting the session, Vijay. Look forward to seeing you.
Yes, thank you.
Thanks a lot, guys,
Thank you so
and
much.
ending the session. Yeah. Take care.